Here is a second example. Two particles of mass 10 and 20 kilograms are connected by a light string which passes over a smooth pulley. The lighter block is on a smooth level plane, while the other block is on a rough plane inclined at 44 degrees to the horizontal. The net frictional force on the block is 35 newtons. This net frictional force is your kinetic friction, by the way. Find the coefficient of friction mu and the tension in the string. So go ahead and try this problem yourself, and when you're ready, come back for the solution. So here is our situation. We have our 10 kilogram particle on a smooth flat plane. We have the reaction force, the tension, and the weight acting here. The second one is on a 44 degree incline. So we have the normal reaction force acting perpendicularly. We have the weight force parallel to the plane. The tension and the friction acting back against the block as well. So firstly, we're told to find the coefficient of friction. Now, the coefficient of friction, mu, so mu times r is the net frictional force, which we've been told is 35 newtons. So mu r is 35 newtons, but r is also 20g cosine 44. So if you actually type this into your calculator, you get about 0.248-ish. So we'll round it to 0.25. However, you don't actually need to put the 0.25 times 20g cos 44 because we know that that friction is amounting to 35 newtons. So we can just include 35 in our resolving equations. So after resolving the forces, tension in the first one is 10 times the acceleration. Because there's one string, the acceleration is constant. So the second one, you have 20g sine 44, so that's the parallel component of the weight, minus the tension, minus the friction, which is 35 newtons, is 20a. Adding these together, we just get 20g sine 44, minus the 35, and then divide by 30 to get our acceleration, which is about 3.37 meters per second squared. So that's the acceleration. The tension in the string is just 10 times the acceleration. So 10 times this is just 33.7 newtons. And that's the solution to that problem.